Notes for lesson dash one or lesson 1-4, solving absolute value equations. So if you missed class or you need to go look at the notes again, this is what that video is for. Again, as needed during the video, go ahead and pause. If you need more time to go ahead and write the notes or more time to actually work out the problems. So this is a pause and write or pause and try as needed. So I'm just going to work through everything and go ahead and get started. So here we have absolute value equations. So what does absolute value actually mean? We're looking at for if a real number A is a positive or zero, the absolute value of A is A. If A is negative, the absolute value of A is the opposite of A. So all this is really saying in the symbols is the exact same thing it says in words, only we're using math. We're just using math symbols instead. So in the models, we'll better look at what we're talking about. So if we're taking the absolute value of 4, we say that's equal to 4. The absolute value of -4 is also equal to 4, because what we're looking at with absolute value is the distance from 0. So it doesn't matter whether I went to the left or to the right, we still moved 4 units left or right, depending if you went negative or positive. So we're gonna go ahead and watch a short video to help us out.
Find the absolute value of x when x is equal to 5, x is equal to -10, and x is equal to -12. So the absolute value, it's almost, the way of writing it is almost more complicated than what it really is. The absolute value is really just the distance of x from 0. Distance from 0. So let me just draw a fast number line over here. So if I were to first, let's just put 0 right over here since we're thinking about the distance from 0. So let's just think about the absolute value. Let's think about the absolute value of x when x is equal to 5. So that's equivalent to the absolute value of 5. We just substituted 5 for x. The absolute value of 5 is the distance of 5 from 0. So you go 1, 2, 3, 4, 5. 5 is exactly 5 to the right of 0. So the absolute value of 5 is just 5. Now, and I think you already get to see this is a pretty straightforward concept. Now let's do something a little more interesting. Absolute value of -10. When x is, or the absolute value of x when x is equal to -10. So let's just put -10 in for x. This is the distance that -10 is from 0. And so let's just go -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. I should extend the number line more. So this right here is -10. So how far is it away from 0? Well, it's 10 to the left of 0. So you put a 10 here. And so in general, absolute value will always be a positive quantity. And when we're thinking about just absolute values of just numbers, it's just going to be really the positive version of that number. Let's do one more. Well, they tell us to do one more. The absolute value of x when x is equal to -12. So we have the absolute value of -12 is going, we don't even have to look at the number line. It's just going to be the positive version of -12. It's just going to be equal to 12. And this is just saying that -12 is 12 away from 0. And we could draw it over here. This -11, -12 is right over here. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 away from 0.
All right, so that was a couple of examples of absolute value with integers. So now we're going to go ahead and give these a try. The absolute value of 3, the absolute value of -7, and the negative absolute value of 9. So go ahead and pause the video and give yourself some time to go ahead and try it. All right, so for A, we have absolute value of 3. Well, the distance from 0 to 3 is 3. The absolute value of -7, the distance from 0 to -7 is 7. And on C, this one is very different because if you notice, we have the negative sign on the outside the absolute value instead of on the inside. So because of that, the negative actually is not affected by the absolute value. One way you can actually think of this is that this is really saying -1 times the absolute value of 9, which is -9, because we're just going to do -1 times 9 to get that -9. So that's one way you can go ahead and look at it. So next we have example 1. We're going to evaluate 2.7 plus the absolute value of 6 minus 2x if x is 4. So we're going to take a look at the word evaluate. That tells me I'm not solving, I just want to know simply what do I get out of this if I plug in 4. So to do this, we're just going to substitute 4 in for every x that we see. So we're going to substitute in 4, and we're going to do 2 times 4 to get 8. So we're going to treat these absolute value symbols the same as if they were parentheses for when we're looking at PEMDAS. We're going to deal with everything on the inside before working on the outside. So we're going to do 6 minus 8 to get -2. The absolute value of -2 is 2. And we're going to go ahead and add to get 4.7 for our answer. Again, pause as needed for you to take notes. So here's your second U try. What is the value of 2.3 minus the absolute value of 3y minus 10 if y equals 2? So go ahead and pause the video and give this a try. All right, so we have 2.3 minus 3y. So instead of writing a y, we're going to substitute in 2 minus 10. And also, anytime you're working with absolute value, do something so that you can tell which the vertical bars are vertical bars versus what are ones. So notice I am writing my ones in a way that you can actually tell that they are a 1 and not a vertical bar. We're going to leave the 2.3 alone. We're going to do 3 times 2 to get 6 minus 10. We're now going to subtract, We're going to subtract 6 from 10, or 10 from 6, and we're going to go ahead and get -4. So the absolute value of -4 is 4, so we still have 2.3. We're keeping this minus sign because we haven't touched that yet, but we have a -4 because of the minus symbol, not the absolute value. So 2.3 minus 4 is -1.7. So our answer here is C. Pause again as needed for you to take notes. All right, our next example, solve the absolute value of y plus 3 equals 8, and check your solutions. So before we go ahead and start this, notice that we actually start with the word case 1. So what we need to recall is that the absolute value of 8 is 8, but so is the absolute value of -8. That also equals 8. So this is why we're going to have case 1 and case 2. So A is going to refer to what's inside the absolute value. B refers to what's on the other side of the equation. So we have y plus 3 equals 8, and we're going to call this our positive case. And the positive case is usually really easy to set up. You don't have to change anything. But we're going to go ahead and solve for y like normal, subtract 3 from both sides, and get y equals 5. So that's our first possible answer. Next, we're going to do case 2, and this is usually what we call the negative case. That's because we're going to leave what's on the inside of the absolute value the same, but we're going to set the other side of the equation to the negative version of what we have. So in this case, it's going to be -8. We're going to still follow the same steps. I'm subtracting 3 from both sides, and we get -11. Now, it's very important to go ahead and check your solutions to make sure that they both work. So we're going to go ahead and do that. We're going to go ahead and substitute 5 in. 5 plus 3 is 8. The absolute value of 8 is 8, so that works. Now we're going to go ahead and try it with -11. -11 plus 3 is -8. The absolute value of -8 is 8, so we are good. So that means we have 2 solutions, both -11 and 5. Again, pause as needed for you to take notes. So here is your u-try. Go ahead and determine what the solution to the absolute value of 2x plus 5 equals 15. Go ahead and pause so that you can have time to work it out yourself. All right, so we're going to go ahead and set up our two cases. 2x plus 5 equals 15. And then I suggest always setting up the both cases at the start so you don't forget to do the second case. So 2x plus 5 equals negative 15. So let's go ahead and start. We're going to subtract 5 from both sides. And we get 2x equals 10. We're going to divide by 2. And we get x equals 5. On the second case, we're still going to subtract 5. In doing that, we're going to get 2x. And in this time, we're going to get negative 20. Because we are going more negative, we're going to divide by 2. And we get x equals negative 10. And again, you should always go back and check your work. So we're going to go ahead and plug in 5 for x. Equals 15. So we're going to get 10 plus 5 in the inside. And we get absolute value of 15 equals 15. Yes, that is true, so we're good with that. So now I'm going to go ahead and plug in negative 10. All right, so we're going to do 2 times negative 10 to get negative 20 and add 5 to that. And we get the absolute value of 15. And that does equal positive 15. So yes, they both work. So our answer is B. Moving on to our next example, we have 6 minus 4t plus 5 equals 0. So when we're looking here, we always want to go ahead and get the absolute value part by itself and move anything else that we have to the other side. So we're going to go ahead and do that. We're going to subtract 5 from both sides so that we get that the absolute value of 6 minus 4t equals negative 5. Since all we have is a constant here, this is never going to be true because I can't take the absolute value of a number and get a negative. So at this point, you can actually go ahead and stop. If you went and continued, when you checked your work, you'd get a false statement on both answers. So to save us time, we just go ahead and stop. And that we find the solution is the empty set. You also might write this as no solution. All right, so moving on, pause as needed again if you need more time to write your notes. So go ahead and give this question a try. What is the solution to the absolute value of 5x minus 2/3 plus 7 equals 0? Go ahead and pause this so you have time to work on it. All right, so again, my first step should be to isolate absolute value to one side and everything else to the other. So to do that, we're going to subtract 7. And we get the absolute value of 5x minus 2/3 equals negative 7. And at this point, we can go ahead and stop. This is not a false statement. So it's going to be no solution, or also known as the empty set, which is answer choice D. All right, for our next example, we now have the absolute value of 8 plus y equals 2y minus 3. We're going to go ahead and work this one out and then check our solutions. So case 1, our positive case, we're going to do 8 plus y equals 2y minus 3. So we're going to go ahead and subtract y from both sides to get 8 equals y minus 3. And now we're going to add 3 to both sides to isolate y. And we get y equals 11. So we're going to move on to case 2, and we're going to take the negative case. So we're going to go ahead and put what's in on the right side of the equation. We're going to stick this in parentheses, and we're going to go ahead and distribute this negative to everything on the inside, which essentially flips our signs so that we get negative 2y plus 3. So now we're going to go ahead and move over the negative 2y by adding 2y to both sides. In doing that, they cancel out on the right, and we're left with 8 plus 3y equals 3. We're now going to subtract 8 from both sides, and we end up with 3y equals negative 5. And now we're going to divide by 3, and we get y is equal to negative 5/3. So now we're going to go ahead and check our answers to see if they both work or if neither of them work. So we're going to go ahead and plug those in and check. So here we're going to start off with our y equals 11. 8 plus 11 is 19. 2 times 11 is 22. And then we're going to do the minus 3. And we find that, yes, it does work. The absolute value of 19 equals 19. Next, we're going to go ahead and look at 5/3. So there's a couple things you need to remember here working with fractions. For us to add fractions or subtract fractions, we need to go ahead and have the same denominator. So 8 is going to be the same thing as 24 over 3. So what this line really says here is 24 over 3 minus 5/3. When we do that, we're going to get 19. 25 minus 5 is 19. Over here, when we multiply, we can always write 2 as 2 over 1, so that we get negative 10 when we multiply across, negative 10/3. Now 3, you need to remember, can be also written as 9 over 3. So we're going to subtract 9 over 3 here. And we're going more negative, so we're going to get negative 19/3. And as we said earlier, we can't take the positive, take an absolute value and get a negative answer, so this does not work. So our answer is actually only 11. Again, pause as needed for you to go ahead and write your notes. All right, for our last question, what is the solution to 3x minus 5 equals the absolute value of 2x plus 1? So to go ahead and pause this so you can give yourself a chance to try it before we work it out. All right, so we're going to go ahead and write both cases. We're going to have 3x minus 5 equals 2x plus 1. And I'm going to go ahead and set up my second case so I don't forget about it. 3x minus 5 equals the negative, We're going to do the negative version of the 3x minus 5. So this one's a little different in that the absolute value is actually on the right-hand side this time. And that is okay. That just means, though, we're going to leave the 2x plus 1 alone. We're going to go with the negative version of 3x minus 5 equals 2x plus 1. So I'll go ahead and set up both of them. So we're going to go ahead and do the first one here. I'm going to go ahead and subtract 2x from both sides. And at the same time, I'm also going to go ahead and add 5 to both sides. So when we do that, the 5's cancel out, the 2x's cancel out, and we're left with x equals 6. On this side, we're going to go ahead and distribute the negative so that we get negative 3x plus 5 equals 2x plus 1. Now you can follow the same pattern we did on the other side if you want to move the 2x, but to get rid of the, I'd rather go ahead and get rid of the negative 3x, so we're going to add 3x to both sides, as well as subtract 1 from both sides at the same time. And when we do that, the 3x's cancel out and the 1's cancel out, and we're left with 4 equals 5x. So we're going to divide both sides by 5. And we get x equals 4/5. And so just looking at this alone, the first thing you should do is like, okay, I'm going to cross out d, can't happen. It's a 4/5, not a 6/5. But moving over here, we're now going to go ahead and check our work. So we're going to do 3 times 6 minus 5 equals the absolute value of 2 times 6 plus 1. So I'm going to get 18 minus 5 equals the absolute value of 12 plus 1. And we're going to get 13 equals the absolute value of 13. Yes, that works. Because you will get the absolute value of 13 is also positive 13. To go ahead and do the 4/5 now, we're going to do 3 times 4/5 minus 5 equals the absolute value of 2 times 4/5 plus 1. So we're going to get 12/5 here when we multiply. I'm going to rewrite 5 as 25 over 5 so that I can go ahead and subtract the fractions. Over here, we're going to get 8 over 5. And I'm going to rewrite 1 as 5 over 5. And of course, that's an absolute value. So we're going to get the absolute value of 13/5. And over here, 12 minus 25 is negative 13. So negative 13/5, this does not work because I can't take the absolute value of a number and get a negative. So that means we're not going to include 4/5 in our answer. So by default, that alone gets us, our answer is B. And that is the end of the notes. So hopefully, again, you can go ahead and rewind this and look at it as needed. But hopefully that helps you out with solving absolute value equations.